plus this 1 plus this 1, right? So my degree is really 4. Now, there are cases where a lot of students can accidentally miss the degree because they might forget, like if there was an x here, for example, just x, that's another x-intercept at the origin, isn't it? So if that was like an x to some power, I have to include that power as well. So be careful if there's ever an x in front that you include him in your degree as well, and your x-intercept discussion. But in this case, it's just coming from these 3 x-intercepts, isn't it? These 3 factors produce these 3 x-intercepts. So what are your x-intercepts? Negative 1 and positive 3. Yeah, and usually just for convention, we will write them from lowest to highest, but if you wrote them out of order, that's fine. Yeah?
We don't do anything with the -2.
Wonderful question. While we don't use that information to tell us anything about an x-intercept, we would, for example, if it said negative 2x or negative 2x to a power, because that x to a power would make this 0, right? If x was 0. But right now, negative 2 would never make this 0. What the negative 2 is telling me, actually, is about the end behavior, right? It's telling me the sign being negative, and as well, it's telling me that there is some stretching going on. So if you were expanding, you'd have to distribute that 2 to everything. So good question. Nope, it doesn't tell me anything about x-intercepts, though.
So wherever there's an x, there's a x.
That's exactly it. There's going to be an x-intercept there. Yeah, great job. And again, where does that come from? It's not just a rule you need to memorize. Think about it, what it means. To be an x-intercept, if you're in factored form, that would mean you're letting y equal 0. And if you're letting y equal 0, that's saying this times this times this times this. How would that equal 0? Well, only if one of the x values somehow would turn that factor into a 0. But a negative 2 would never do that. Good questions. All right, multiplicities. We look at the powers of each factor that the zeros came from. So for negative 3, its power for that factor was a 2, which I like to remind myself is even. Negative 1 came from this factor, whose multiplicity was a 1, which is odd. Positive 3 came from this factor, whose multiplicity was 1, which is still odd. So even if they didn't ask me for this part, I would need this for my graph, wouldn't I? What is the multiplicity telling me? Even multiplicities tell me that I touch or bounce off. Whichever one you prefer to write, I accept. Okay. Odd multiplicities tell me that I cross or cut through. So both of those are doing that. Again, we mentioned already, I'll write it on the corner here, that the degree of this polynomial was 4, right? I always like to remind myself as I go through the problem to make sure I've accounted for everything, right? That means I had up to 4 x-intercepts. Let's see what I ended up with. I have 3 x-intercepts, so you might think, well, what happened? This one was repeated, so that accounts for all 4 pieces, right? This one was repeated, and then I had the other 2, so there's 4 right there. All right. As far as maximum number of turning points, last question, it's always the degree minus 1. So in this case, 4 minus 1 is equal to 3. So I could have up to 3 turns. Do I have to have all 3? No. I can probably have 1 or 2 or 3 in this case. I won't make us graph it because it didn't ask us to. The next problem we'll get that practice. But are there any questions on how to get these items from the equation in factored form?